In this video, I will show you how to write and graph the equation of an ellipse, regardless of whether or not the center is at the origin. We need to worry about whether or not the ellipse is horizontal, or I could say whether the major axis from one side to the other the long way is horizontal, or whether the major axis is vertical. Notice, as far as the equations go, the only difference between the equation for a horizontal ellipse and a vertical ellipse is here I have a squared under the x term, and here a squared is under the y term instead of b squared. This makes a difference because we consider a squared to always be the larger denominator. So look at it that way. Wherever you see the a squared, we're talking about the larger denominator. So if the larger denominator is in the x term, then it's going to be longer in the x direction, so horizontal major axis. If the larger denominator is with the y term, then it's going to be longer in the y direction, a vertical major axis. These points here and here are called the foci. Notice that the foci, plural of focus, will always be on the major axis. They always go the long way. They will always be lined up with the vertices. Speaking of vertices, this is a vertex and this is a vertex. Okay, the points on either end the long way are vertices. This is a vertex and this is a vertex. If you go the short way, the points on either side are called co-vertices. So these two red dots are co-vertices. This is a co-vertex, this is a co-vertex. So here's everything sort of labeled out for you. Now remember that if you're looking at the standard form equation, the h and k right here are the coordinates of the center. So this is h comma k. All right, h comma k, that's the center. So if I wanted to write the coordinates of the vertices, I can do that. I can make expressions for the vertices even if I don't have actual numbers for h and k. What you have to understand is this distance right here from the center out to a vertex is called a. All right, the same a we talk about when I say a squared. So the coordinates of the vertex, if we're looking horizontally, should start with the h value, and we're going a to the right. So the coordinates of this vertex on the right hand side, the x value should be h plus a. Starting from h and I'm going a to the right. The y value should be k because these are at the same height. Alright, so these are the coordinates of the vertex on the right. Similarly, the vertex on the left should be at h minus a because we're going a to the left. And then k is still the y value. Okay, so you should be able to write these coordinates even if you don't have any numbers. So what about the co-vertices? Oh, you know what? Let's do the same thing for the vertices that are vertical before we move on. So what about this bottom vertex? So the x coordinate should be the same as the center. Okay, because these are the same distance to the left and right. So the x coordinate of this vertex should be h. The thing that's changing is the y coordinate. So this point, again, this distance right here is a. So I'm going a down. So this should be the k value minus a. So this is going to be k minus a because I'm going a down. And then the y value of this vertex, starting from the k value, and we're going up a. So this should be the k value plus a is what you're going to have. Okay, so the center is still h comma k, but the vertices, when we're talking vertical, should be h comma k minus a, and then h comma k plus a. Okay, now let's switch over and talk about the co-vertices. Alright, having done the vertices, we should be able to do the co-vertices pretty quickly. Let's see, which coordinate should be the same as the center? Well, in this image, all three of these points have the same x coordinate, alright, because they're all lined up on the same x value. So the h of the center should be the same x value for my co-vertices. Okay, they are all h to the left or right. The thing that's going to change will be the y coordinate. Now, this vertical distance is what we call b, the distance from the center to a co-vertex. That's why if we start from the value k, the y value of the center, we're going to go up b, and then we're going to go down b. So this y value will be k plus b, and this y value will be k minus b. So those are the coordinates of your co-vertices. H comma k minus b, and then h comma k plus b. Alright, and similarly, if we look at the horizontal co-vertices, well, if we look at the case where the ellipse is vertical, but this b value is horizontal, the coordinate that they have in common will be the k value. All three of these points should have the same y value, which is k. Alright, now the thing that's changing is the x value. Starting from the x value of the center, which is h, the x value of this co-vertex should be h minus b. The y value should match the k. And for this co-vertex, the x value should be h plus b. And then the y value should be k, same as the center. Okay, now how about the foci? It's going to be very similar, but the foci depend on the c value. Okay, and alright, so remember that the c value is the distance from the center to the focus. So this will be the c value right here. So with that in mind, let's think about which coordinates should be the same. The y coordinates of all of these points, the center, the vertices, and the foci, all of these have the same y value. They're all at the same height. So the y value will be k, so we don't have to worry about that. But focus on the x value. Again, starting from the center, which has an x value of h, we're going right c, and then we're going left c. So this focus will have an x value of h plus c, y value of k, like we said. And this focus will have coordinates h minus c with a y value of k. Okay, similarly, if we look at the vertical ellipse, And again, keeping in mind that this distance right here is C. See how these are lined up vertically? All of these 5 points will have the same x value, which will simply be h. So I don't need to worry about the x value because they all have the same x value as the center because of the way they're lined up. The thing that's changing now is the y value. So starting from the y value of the center, which is k, this focus is up c, so that's k plus c, while this focus, x value of h, but the y value is down c, so that's k minus c. Alright, I hope you understand that these expressions that we're building are not something to memorize. I just want you to understand so you can apply this same intuition to the problems as we begin them. Remember the relationships between a, b, and c. For an ellipse, c squared is equal to a squared minus b squared. And the eccentricity, which we denote by using the letter E, is always C over A. Alright, remember that the eccentricity reflects how close or far the ellipse is from circular. Alright, so if you have an ellipse that is very circular, the closer to being a circle, the smaller the E value. So this ellipse would have a very low E value, close to 0. Whereas this ellipse, which is very not circular, would have a bigger E value, farther away from 0. Okay, let's go ahead and do an actual problem. I would really like to start with the center. So see how the numerator here is simply y squared. There's nothing added or subtracted. That tells me that the y coordinate is going to be 0. That also, I'm just noticing that this is sort of backwards from what we're used to, and that's bothering me, so I'm going to change it. Normally we put the x term first, so I'm just going to use my prerogative and rewrite it. Okay, so I'm going to put the x term first like we normally do. Okay, and as long as I'm doing that, I might as well go ahead and show that this y squared could be thought of as y minus 0 squared. So you can see that the coordinates of the center will be 3, 0. Notice I do the opposite of these, so if it's x minus 3, it's going to be a positive 3. Okay, so 3, 0. So let's go ahead and graph as we go. So the center is 3, 0, which is right here. Okay, the larger number is the one that we consider to be a squared. So if a squared is 36, that of course means that a is 6. Okay, and you know what, I'm still using the backwards version. I choose to switch and use my new version. So again, so this is my a squared is 36. The a squared is always going to be the bigger denominator, which does mean that a is 6. Now, notice that a squared is with the y term. That means this a value of 6 is going to be performed in the y direction. So when I do my plus and minus 6, I will do it vertically. So I'm going to go up 6 and down 6 from here. Okay, so these are my vertices. So this point right here is the point 3 comma negative 6. So that's a vertex. And this point is the point 3 comma 6, another vertex. Okay, now the smaller denominator is going to be b squared. So b squared is 9, which of course means that b is 3. Notice that the b squared is with the x term, which means my plus and minus 3 will be done in the x direction. So I will go 3 to the right and 3 to the left. These are my co-vertices, 0, comma 0, and 6, comma 0. Okay, I really could draw the ellipse right now, but I feel like I will save that for the end. So let's go ahead and figure out the c value and therefore the foci. So remember that the relationship is c squared is equal to a squared minus b squared. So c squared is going to equal 36 minus 9. So c squared is equal to 27, which means that c is equal to the square root of 27. 27 is 9 times 3, which means that c is equal to 3 radical 3. Now, for the purposes of graphing, it's useful to know a decimal approximation, even though I will not use that in the labeling of c or the foci. Okay, so c is approximately, should make these wavy, approximately 5.2. We know that the foci will always be on the major axis, which runs the long way from end to end of the ellipse. So if I start at the center, if I go up 5.2 and down 5.2, that's where my foci will be. So if I go up 5.2, that's about here. There's a focus. If I go down 5.2, that's about here. So these green dots are my foci. Now, just like we did in the problem above, let's carefully think about the coordinates. Notice how all 5 of these points will have the same x value. They are all lined up at 3 as far as the x-axis is concerned. So they all have an x value of 3. All right, so these foci will both be 3 comma something. Okay, I'm leaving a little extra space for the y value because I'm going to have an expression in here. So for the y value, I need to start by looking at the y value of the center. Okay, in this case it's pretty simple because the center here is 3 comma 0. The y value is 0, so that makes it a little bit easier than it normally would be. Because we're doing 0 and then we're going up c, which is 3 radical 3. So if I go up 3 radical 3, 0 plus 3 radical 3, we're just talking about 3 radical 3. But sometimes, if this y value had been, say, 2, then I'd have to write 2 plus 3 radical 3. But in this case, it's a little simpler. So if I go down c, in other words, I'm going down 3 radical 3, so I'm at negative 3 radical 3. And then we can go ahead and draw the ellipse, and we're done. I almost forgot about the eccentricity. We know the eccentricity is c over a. In this case, that would be 3 radical 3 over 6. But this reduces, right? 3 over 6, that's 1/2. So this whole thing should reduce down to radical 3 over 2. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.